For the 2018 edition of my simulations course at edx.org, we are recommending that you use ANSYS version 18.2, which is the latest version as I speak. The main difference between version 18.2 and older versions is that SpaceClaim is the default geometry engine. I'm updating a few of the videos in the bike rank module in my EDX course to version 18.2. Most of the videos will stay with the older version because there are really no changes between that older version and version 18.2. And even if there are, the changes might be minor, and we'll indicate that with annotations within the older video. So you have to get used to seeing videos recorded in different versions of ANSYS. In the geometry step, we will define the domain over which we want to solve the governing equations. And if I go back to the pre-analysis slide, we can see that the domain is defined by by this particular geometry. So we'll import that, and you should find a file, a download link on the tutorial page under geometry in the geometry step, where you can download this geometry. It's in parasolid format. So find that link and download the geometry, and then start ANSYS Workbench. So I'll come in here and search for Workbench and start Workbench 18.2. And after the Workbench interface comes up, under Analysis Systems, highlight Static Structural and drag it into the project page. And I'll rename this particular analysis instance as crank. You can call it whatever. And in this process, we have actually given it an important clue about what is the mathematical model that we want ANSYS to solve. More on that later. And right-click on geometry and say Import Geometry and Browse. And go to the folder where you downloaded this geometry file, and it's you can see this name, and that particular extension x_t is used for parasolid files. So highlight that and say Open, and actually that geometry has come in, and I believe this parasolid this P means that the geometry is parasolid. And then I can actually go in, I can go in and start model and discretizing the domain into elements and nodes. I can go into meshing. But before that, let's take a peek at the geometry. So I'll go under Geometry, I'll right click, and I'll say Edit Geometry in SpaceClaim. It'll take a few moments for SpaceClaim to come up. I'll say close here. And if I go and expand these, and if I move the cursor over these three part names, I will see those corresponding parts. And we are going to analyze only this part over here that I've highlighted right now. And we will suppress the other parts. We can do the suppression right here. You can say suppress for physics, which we won't do. We will suppress it later within ANSYS Mechanical, and the two are equivalent. But we'll leave this over here. So the geometry has come in. There's really nothing to do. So I can just exit SpaceClaim. And I can save the project. So I'll say File, Save, and go to my working folder and give it an appropriate name. Okay, so I'll say crank. And in the working folder, that I created a file and an associated folder. So now we have defined the domain over which we want ANSYS to solve our governing equations, which are the equilibrium equations, as we saw in pre-analysis. And the next step, we will move to meshing, where we discretize this domain into elements and nodes. Before that, I want to mention that students often ask me that, what is the best way to bring in CAD geometries into ANSYS? I asked an ANSYS engineer about this, and he recommended, try bringing in the native CAD file. So if you have SolidWorks, for instance, a native SolidWorks file or Inventor and so on, and for that you need, a teaching or research version of ANSYS. I believe you can't do that in the student version. And in fact, you can have bidirectional connectivity between, the CAD software such as SolidWorks and ANSYS, so that as you make changes in ANSYS, in SolidWorks, that new geometry will automatically come into ANSYS. And so try the native geometry, and if you can't do that, or if you don't have access to the teaching or the research version of ANSYS, you can try, saving the geometry in your CAD software as Parasolid and bringing in the Parasolid file into ANSYS. And this is what we've done over here. The geometry is created in SolidWorks. And third, you can also try the step format. And so between these formats, especially as you go to more complicated CAD geometries, you should be successful in bringing your CAD geometry into ANSYS.